point clouds as well. Okay. And then finally, there was a little bit of an art with the evaluation version to do replays of ROS bags. So a lot of the use cases have been people will go out and actually collect the ROS bag with the Lidar sensor, and they want to do a post-processing or they want to run it again afterwards. How we had set it up previously, you had to fiddle with the replay speed and so on to kind of match to your processing capabilities so that you can actually create a good point cloud. We kind of streamlined that. So now you can just run a post-process on the ROS bag and it'll process the entire ROS bag. And then use whatever resources is available to basically create the final result. So you have less variability in terms of the result, depending on the system resources. That's been one of the key requests that we've had for the evaluation. Okay, so let's take a look at some of the changes in depth and basically see how these things affect some of the scans. So I'll actually walk you through this. Part of the change here is we have a new launch file format, and the configuration file that we've been using used to be a YAML file, but we replaced that with a .ini file with a slightly different format. So I'll go through that as well, so you can see what it looks like and which areas that you probably want to fiddle and play around with. Okay, so this is an example of what we're including in the new evaluation package. This should be available now as we speak. It wasn't available prior to this webinar, so if you grabbed a previous version, just send us a note, and then I'll be happy to send you an updated version that kind of uses the new capabilities. So some of the levers that we've kind of added here, I think a lot of this was existing previously. So running the LiDAR in tracking mode only, just optimizing the graph automatically. You can decide whether to do loop closure or not. And then this we kind of introduced. It's basically an idea of how much overlap do you want before you actually close a loop on an environment. So if you set this really small, I think it'll trigger loop closures more readily, but that's not always a good thing because once you actually close a loop and it doesn't close a loop properly, for example, it gets fooled into closing a loop on an area that it actually hasn't been back to, it'll basically wreck the map. So you want to actually maintain a fairly large number so that you're certain that it's actually a proper loop closure. So that's an item that you can fiddle around with. The minimum point distance and maximum point distance, again, this is what I kind of talked about earlier. So the minimum point will basically avoid capturing things immediately around the sensor, like yourself or the vehicle. And the maximum point is basically at the point where we throw away all the data coming in. For the voxel size, I'll show you examples on this one, but for indoor scenarios, you probably want to reduce the voxel size. This unit is in meters. All our units are in meters. So a voxel is basically a volume in space, and so it's a 10 centimeter by 10 centimeter voxelization of the world. So indoor environments, you want to make sure that this is fairly small, 0.1, 0.2, even 0.05 typically works, especially if it's a tight space. It just lets you capture more of the features of the room and use that for tracking purposes. And then as the minimum match to track, this is an element that you want to tweak based on how sparse the environment is in terms of features. And if you have a lot of things around you, you can increase the number to make sure that you're tracking within that space fairly well. And then minimum matches to relocalize. I usually don't touch this. This is when in a kidnapping scenario, if the device or robot comes on at some random area, you want to make sure that it kind of relocalizes within that space and knows where it is. So you want to make sure that it has a good grasp of all the features around you and kind of say, okay, I'm sure I'm actually here, and this is where I'm starting. All the other stuff I probably wouldn't touch. So understored with IMU, you probably want to keep that true. And then understored with lidar motion, yes, you want to keep that. Kind of prevents motion blur. And then I'll talk a little bit about these things here, the store all frames, poses and all that. I think you can ignore most of it. You can play around with it, but just from experience, the only thing that you may want to play around with is store all frames. And so this will basically enable you to create high resolution point clouds. And so you'll use store all frames in combination with tracking voxel size. And then if you, for example, if you make the voxel size 0.05, and then you turn on store all frames, you'll basically get a really detailed point cloud of the area. It'll take longer to process, but the point cloud is fairly nice. So I'll leave this here. I think we will share the slides, right, Henry? Or at least some type of document.
We can share the slides.
Okay. And so you'll have this information in terms of what each of these, or at least the important elements of what each of these do. Okay. All right. Thanks for bearing with me with all this information so far. And now we'll go into demo. Okay. All right. I hope you can see all this. I just have the .ini file and the launch files open for your information. I think we are including both an Ouster_dense .ini and an Ouster_preview.ini. And so between the two, what they do is the only thing that's different is basically the voxel size. So in the dense voxel size, as you can see, we're looking at a 5 centimeter voxel, and then we turned on store all frames. And then I think we increased the min match to 400, while in the preview mode, we're using a much larger voxel. So it's basically a 30 centimeter voxel. And then we don't store all the frames, and we kind of reduce the minimum matches in this scenario. Okay, so let's take a sample case here. Okay, so as you can see in this example here, we're going to use the preview.ini version. And so in this case, what you'll see is a fairly sparser point cloud. It is an office space, so you'll still get quite a bit of detail. Let's take a look at what this looks like. Okay, so you can see immediately out of the box, I mean, it does look pretty dense. Right now, I'm running in the post-process mode, and so it's not real time. And as you can see, it's actually running faster than real time. So use all the available processing resources that it has for that device, and basically run through the entire ROS flag and not drop any frames. Okay, so this you'll see running pretty fast. Let me just switch over. I think it gives you a good idea of, you know, as you can see, because the voxels are larger, the point cloud is it is a bit more rough. You can see the important details like the dividers and the halls and stuff like that, but you're getting more of a rough view. Let me just switch over. Okay. So in this case here, let me just change this to dense. Okay. It's the same ROS bag. We're just running it in the more dense mode. If you remember from the settings, now the voxel size is 5 centimeters, and as you can see, you're getting a lot more detail. And at the same time, you're processing a lot more data, so it's actually running a lot slower as well. I would say it's not real time. It's probably, I don't think I walk that slow, but yeah, maybe a quarter speed at this point. But you'll have to play around with the voxel size and try to see what your sweet spot is. At this point, I mean, you're getting a lot more detail. The Arvis visualizer, it does a good job. It gives you a good sense. But once you actually export this into a PLY format, you're going to get a lot more detail from the point cloud. I'll let that run. And I think I do have a ROS bag, a PLY that I created from this. So we'll take a look at that. And exporting to PLY is all that information is captured inside our document that we provide, or even during the webinar for 0 to SLAM in 30 minutes. Okay, so this is basically the same office area. I should have filtered it a little bit, but as you can see, yeah, the visualization is a little more richer here, and then you can start colorizing and playing around with the point cloud. Okay. All right. Okay, so moving on. Let's take a look at a forest example. And so these scans are done with a handheld scanner. And so you do get this motion, natural motion as you move, as well as when you actually make turns, you'll basically typically do rapid turns. And so there may be some blurring, but using the IMU, we're able to kind of zero out most of the noise that you would see from this type of scans. Okay. Okay, so this is a small forest. We'll look at a dense scan. Actually, this takes a while, so I'll let it run, and then I'll show you the result of the scan here. Again, this is an example where you're looking for tree density, volume of the trees, height of the trees, and so on. So you can do an estimate of biomass for forestry, looking to see if you can start harvesting and which trees you can start harvesting, and so on. This is non-dense one.